All right, team, I'm giving just a quick example here on how to do unit conversions in both metric and imperial units using the example of drag force based on a question I got from the students. So I started with just writing out the equation for drag force here, showing that the drag force total is equal to 1/2 times the density rho times the velocity of the object squared times the coefficient of drag, CD, times the area of the object going through the flow. And then I just defined the breakdown of what the units of force are in both of these systems. So 1 Newton is equal to 1 kilogram per meter per second squared. So then 1 pound force is equal to 386.1 pounds mass times inches per second squared. So in this instance, it's just 1-to-1 in metric because of the way the variables are defined, that you do not need the gravitational constant in there. But in the imperial system, you need to include this 386.1 for the standard Earth gravitational acceleration. So let's start with rho here, the density, and define its variable. Rho is the amount of mass per volume. So in metric, that's kilograms per meter cubed. And in imperial units, it's pounds mass per inch cubed. And throughout this, we're just going to use inches as our imperial unit of length. This could also be done with feet as the imperial unit of length, and the gravitational constant in this case would be 32.2 feet per second squared. Now, moving on to velocity, that's how much distance you travel per time. And so that in metric is meters per second, and in imperial units is inches per second. Then here, the coefficient of drag is actually unitless. And then the area, of course, is going to be meters squared or inches squared. So let's write out the variables in the equation. Force drag equals newtons of force is equal to kilograms per meter cubed times velocity squared. So we'll just call that meters squared per second squared times the coefficient of drag, unitless, we'll just give that unity, or 1, and then times the area. So again, a meters squared in the numerator here. And then in imperial units, we can do pounds force is equal to 386.1 times pounds mass per inch cubed times inches squared per second squared times unity for the coefficient of drag, which is unitless, times area, inches squared again. Now what happens here is we can start canceling out variables. So here in the numerator, we have 2 meters that are being squared and 3 in the denominator that are being reduced. So we need to add the 2 together. It would be meters to the 4th minus meters to the third, and you're left with just a single meter on the top with the entire meter in the denominator removed. So in this instance, what's left is newtons is equal to kilograms divided by second squared, from here of course, times a singular meters. And if we go back to our initial confirmation, the units relate exactly as planned. Now here in this example, we have again 4 minus 3, just leaves us with a single inch in the numerator. And we're left with pounds force is equal to 386.1 pounds mass from here times inches per second squared, which we can confirm again is from here. I hope this helps in carrying units through for engineering solutions of force, and that you've been able to understand and follow my work and read my handwriting.